Welcome everyone. My name is Valto Loikkanen and I'm the senior advisor here at Startup Commons. And I'm also here joined today with Oscar Ramirez, who's on the other location. Oscar is the CEO of Startup Commons. Thanks everyone for joining, and let's dive into the topics of today. We have a lot of topics to cover. We try to give both an overview for many of these topics and then touch some of these topics along the way and try to fit everything into the time window that we have reserved for about 2 hours or so. We want to kind of open up this topic to understand why the innovation ecosystems are moving towards open standards framework. So this is not only something that relates to what we are doing in context of startup ecosystems and the connecting innovation and entrepreneurship ecosystem, but this is also what's happening in all of the ecosystems on digital side. So being that business ecosystems, being those extended ecosystems of specific platforms and so forth. So there's an underlying technology momentum and business model momentum in regards of this open development frameworks and open development and open standards that are happening also in some industries where, for example, finance industry is a great case example as well to look into. But to dive into the why this digital is so important component when we look at the startup ecosystem development overall, it is the competition in a global level where there's countries and local ecosystems, city level ecosystems, state level ecosystem, regional and national ecosystems. And everyone basically are trying to develop their ecosystems, not only from the global competitiveness perspective, but also, of course, naturally for feeding their own innovation out of their own country, getting those to the market, helping to develop the economy and grow the economy and create jobs and improve the societies with the new innovations and so forth. But at the same time, a lot of focus goes into this perspective of how are different ecosystems doing and benchmarking at various different levels of this progress. And in this context, Startup Genome is doing really great work on doing this activity at global level, looking and doing this benchmarking and evaluating different local city level ecosystems and depending on some cities and countries are almost the same, and in bigger countries there are multiple different cities to rank different separately somewhere in some areas that is happening at the regional level, but the notion is that it's somehow physically or geographically condensed ecosystem region focusing on developing startups out of that region. And this is an annual report. Over the years, Startup Genome collects the information from various different aspects and then combines the research out of that and publishes the annual report, including the ranking and then all of the finding on different levels of the ecosystem development. And regardless of knowing that there's a lot of information that it doesn't get into the reports, a lot of it is survey based and so forth, it is one of the best and ongoing systematic work to rank the different developments. And this is one of the key pieces that a lot of eyes are focused on those who work on ecosystem development on the annual basis. So when we talk about the ecosystem, we really like that to be understood, that it is the invisible infrastructure that makes the connections within the different organizations and people. And there's a difference between an ecosystem and a community, for example. That community is much smaller, and there can be multiple communities in the ecosystem, and the communities themselves can also be just organic groups of individuals working together. But also the ecosystem is a good analogy because it's not meant to be controlled, it's not meant to be owned by anyone. It is the collective ecosystem that basically impacts everyone that are part of it, and everyone can benefit from it, and everyone also contributes to it in different ways, either negatively or positively, but they have an impact for the ecosystem. So as such, the ecosystem development is a collective effort of all parties involved, but the ecosystem as a terminology is like an invisible infrastructure to understand how all of these interact with each other. And in the context of researching the effectiveness and the growth factors for any ecosystem in the development, there was a research done in US by the Chamber of Commerce and some other actors, looking at multiple different ecosystems already several years back, when they concluded after all of the findings pretty much that the connectivity is the single biggest factor for growth. So if looking to develop and grow the ecosystem and grow the output of the ecosystem, the connectivity is the single biggest factor to focus on. It's not the only factor, but it is the factor that is also associated with all the other developments. And when we look at then the ability of what comes out of that connectivity, and also what is the real competitive advantage for the ecosystem level, it's the speed of collective execution and learning. So that's the new unfair advantage. So if we think about individual startups or even bigger companies, the faster they are able to put new things out, learn from them, and apply their learnings to iterate to the next person or improve the approach, the faster the whole thing will develop, whatever that thing is. Is it a company? Is it a product? Is it a startup? Is it an ecosystem? And if we think of that iteration cycle, and we think of the execution and learning, then the key piece of that is data, information, and knowledge. So if there is no data about what's happening in the ecosystem, if there is no information about who's part of the ecosystem, what are their roles, what are their functions, how many startups there is, what are the support services, what are their access criteria, what are they focusing on, and so forth. And if there is no accumulating knowledge out of this data and information that would be made widely available, then that learning would be very slow. So data, information, and knowledge are the gasoline of the speed of collective execution and learning for the competitive advantage. And the data infrastructure is the engine that makes the data flow. So that is the engine in the whole system. So this is how the whole digital side comes together, that it needs the connectivity as the factor of growth, how people and information is connected, how information is flowing, where is the trust between different actors, how well do they know who can help them at what aspect, and so forth. Having this information flowing fast for improving own execution and learning cycles is the unfair advantage for all of the parties developing companies and their services, and the data and information and knowledge is the gasoline. But it all needs this infrastructure to bring it all together, and that is what we have been focusing on in parallel to all of the other development that we do on the, I would say, the business and non-digital operational side of Startup Commons to improve the overall knowledge So the data side and the digital side, we have focused on bringing as part of our development work that we have been doing with more than 30 ecosystems on the ground level so far in the past 5 or 6 years or so. And the global data economy is predicted at $3 trillion. So that's also that there's a lot of value in that data beyond utilizing it for knowledge and data-driven development and data-driven decision making. Data itself is a valuable asset for new innovations, for new startup, for new economic growth. It's a renewable asset, so it can be multiplied basically without any cost. It can be reused, it can be used one data set in hundreds of different applications and so forth. So data is by itself is a new asset also for new innovators in the startup ecosystem and of course in the development of the ecosystem as a whole. And another number in regards of the data, when we look at just the personalized data, so that is the data about the people and individuals and about the citizens, that data alone in Europe is predicted to already next year to be worth 1 trillion euros for the European economy, almost 8% of the European GDP. So there's, in addition to data being valuable for the basic competitiveness, it's also an extremely valuable asset to start utilizing that as an asset for new innovation and competitiveness and economic growth. In addition, data is power, and with any power, you have great responsibilities. So you can use that data for good purposes, you can use it for bad purposes, and that's why it's also important for what purposes that data is available, to who it is available, who is the owner of that data. But it should not be tried to limit, because there's a two-sided thing that on one hand it's extremely important for the economic growth, it's important for learning, but it can also be misused in wrong hands, and that's why there needs to be right considerations about how that data is used and in which way and where does it originate, to what purposes it's used and so forth. So there isn't just one data, there's multiple different types of data, like the personal data and statistical data like the startup ecosystem rankings and so forth. So with data comes the ability to use that data in different ways, and it can be used to identify patterns, it can be used to drive opinions, it can be used to do many things. One of the key things for the use of data that is kind of the next logical step out of just using it for doing better informed decisions and faster activities is to do automation out of that data. So data activities triggering activities for automated actions. But again, there is no automation if there is no data. So if considering the artificial intelligence developments, putting automation, putting automated identifying of patterns and so forth, any type of AI application considerations for any application, but at the same time also for anything at the developing startup ecosystem, so individual activities there like automated matching or better matching of co-founders or evaluating potentials of ideas, or any type of kind of interesting vision that there might be. If there is no data, there is no AI. And if there's only poor data that comes from surveys or secondary crowdsourced data collection efforts or individual project-based data collection projects, that is not enough to develop effective artificial intelligence models and services. So the key point here is that if there isn't enough of this type of thought processes happening, then that global competitiveness in developing the ecosystems is basically going to set back not only by 6 months or a couple of months or a couple of years. Those who start on this level on the digital side will continue to have accelerating competitive advantage with more accumulating data being available for them to make better decisions, more informed decisions, faster iterations, and so forth. So it's really, really hard to also then start to catch up with those developments, not only because of the technology, but of what that data is available and from how long time of that data have been collected from how many different aspects, but also then how the mindsets of having that type of data all the time available for different use cases will inspire the thought process of developing new things. But what does all of this mean then for an ecosystem? And each of the ecosystems, of course, they need to build their own vision, and they need to come up with what that vision looks like for them in multiple different perspectives, and also taking into account of what is the current maturity level of the ecosystem, and so forth. But at the same time, each of the organizations and those developing now focused specifically on the digital side, developing these solutions should of course have their own vision. And if there is no ecosystem level vision, then basically to have own, and when there is or when contributing to that, making sure that those visions are aligned with the ecosystem level. But we have visualized this type of simple picture to help communicate how does all of this can come together in a sense of ecosystem user. So really thinking of how all of the hard work that would go into making the data flow, making the automations happen in the background, building all of the infrastructure to make it work, and having people to really make sure that the right data flows to right places and no wrong data uses and so forth. But how it all comes down together for the end user, it could be when the voice interfaces are developing better and those digital assistants or AIs are dependent on what data is available for them. Where do they have access to? Who has made access to their information available and so forth. That this is an idea where you could simply ask things about the ecosystem and have those things basically delivered for you in a simple answer in a form that takes into account your profile, your company's profile, your service profile, what are you trying to do, and simply getting answers as needed. So this is just to give an idea of where that vision could be taking as one direction. And we can all imagine how difficult these types of experiences are, whether it's this or whether it's finding your co-founder or whether it's finding your mentor or any other type of help, or even being aware of what would be available to you, depending on your company's development phase or the global connectivity that you would like to build with other ecosystems and so forth. So hopefully this inspires the vision of where all of this heavy lifting and heavy work could be leading to. So one aspect of our presentation for today, and also in the large parts our work at Startup Commons, is that there is a big divide. This is a visualization just to show we all understand the left and the right brain logic, that there is this kind of logical side of our brain, and then there's the emotional side, the artistic side of our brains. And but this analogy, or this is a fact, but this can be used as an analogy also for how the world is pretty much divided between understanding digital and understanding business, non-digital aspects. So if we think about how the typical skill sets and departments and even like companies are divided, there are those who understand technology, that really understand it at the deeper level, who have internalized the technical side, the digital aspects, and all of those various things in a very detailed level. And then there are those who focus on the non-digital side, non-technical stuff, the people, the numbers, the business, to analytics, to business models, to strategies, and so forth. And one of the key things that there is very few people actually in the whole world that are like, there's a small group of people, or very small percentage of people who naturally live and think of both of these extensively. And big part of that is that traditionally these have been like separated skill sets, so separated educational track. There is very little of digital business education, for example, or business education driven by digital solutions. And that's just the nature of how the education have come about, how the technology has come about. They have been separated similarly as entrepreneurship has been separated from traditional. It's kind of partly there, but it's not really like key part. But the key notion of what we want to try to do is to try to communicate these things that we are developing, so that we help bridge also this understanding between these two different worlds. Because the reality is that those who only think things from technical perspective will always suffer to find rationale between the business logic and the non-technical elements. And the same applies for if not being able to go to sleep with the business problem and come out in the morning, having wake up, having analyzed that with the digital solution perspective and having an answer, means that there's limited capacity to think of what can be achieved with digital side of activities. So it's important that there's more of this equal mutual understanding between these two silos inside companies, inside organizations, inside ecosystems. And that's a key part for how we want to try to structure these things without making them too separate from each other. And it's a constant struggle for us also. Where does the line go? When are we talking too technical, and when are we communicating too abstract concepts when talking to developers, when we are talking about too complex technical things when talking to those who are not so much involved with technical stuff. But anyway, that's where we want to focus as part of this presentation as well. So a traditional organization is something that basically, if we think any of those companies that are not Facebooks and Googles and who have not born as a digital companies from the beginning, the typical digital use and application use is basically this kind of a box of software or software to a specific business function in an organization. And then the information and the organization's processes are basically communicated through people, and they are going through from people to people, cross department, and that is a typical how the organizations have emerged to basically use software to help them run their operations and business. And there's a whole struggle between the organization going through the digital transformation to become more digitally native. And if we look at a digital organization, then basically that is something where all of the processes are connected at the digital level, on the application level, between the applications. And then these processes, when they need to be changed, they are changed at the application level, and they always work every time the same way after that. So basically, as individual users or consumers of applications, we can experience that very easily when we use Gmails or Facebooks or Google services. There is no, the user interface just changes for us. There is some new features added. Maybe there's some helpful, self-learning content. Maybe there's educational videos there, but there is no training session for us as users. Hey, you need to come here, register for this event, and then we go there, and there's some manager explaining to us how the new process is going to happen and so forth. So that's the very big difference between, I would say, more analog organization versus more digital organization. And this is also, when we take that into the ecosystem level, that's the similar struggle that is, what is the work to be done is to move from this type of information passes from people to people versus information passes through application to application, and all of the people can be informed depending on their access right to their own, to that information. And that information can be made available in their own applications that they use. They don't need to go into a different application to consume that information. So this is something that it's important to understand the big impact of this digital that it can have in business and economy at large. And the biggest and the kind of the strongest actor who works in multiple different industries in this context is, of course, Amazon. And of course, there are the equivalents in if we go to China, it's a whole different ballgame. But if we look at the more Western and open markets, we can look at Amazon as a case. And if we think that what Amazon did 17 years ago, in 2002, so 17 years ago, that's a long time, that's a long of headway that they have been able to accumulate and learn, which they are then applying. This is a topic from a letter that Amazon shared with their whole organization. Jeff Bezos basically sent this letter with these topics to the whole organization. So basically, this was the time and how Jeff Bezos drove through that digital transformation inside the organization. Well, they were doing digitally for external services and customers, but the key competitiveness came when they drove the digital transformation to do everything inside the organization the same way as they would do interface between them as a company, digital company serving digitally their customers. They went through this process to separate all of the departments and creating service interfaces between the departments. And it was basically forbidden to pass any information through people, because people can act like a broken phone. Its information can be misunderstood. It can be like a broken phone. You put enough people in the line and the message that was started and you listen at the end, it doesn't work. So basically, to the point where between departments there was a service interface, and it was forbidden to also give access to anyone else into the interface that one department was using. And at the same time saying it doesn't matter what technologies are used. So there wasn't a technology question that you need to use this language software or you need to use this databases behind. It's not about technology, it's about strategy. And at the same time, the one of the key aspects was that at that time they already decided that any of these interfaces need to be able to be made also externally available. So that means that they can have external department, or they can develop connectivities with applications beyond their own organization, or let others access their organization information outside of their organizations. And as you can say, it was pretty straightforward. There wasn't about question whether this is going to happen or not. But the key point here is just like, when does it happen, how ahead of time it was, and what has then have been the amazing outcomes of this type of thing. And of course, if we think about like ecosystem level, there is, and that's a good thing, there is no dictator who can basically say that this is what's going to happen, and even if there would be, it wouldn't, not everyone would comply with that, and that's a good thing. So, but the thought process that what these interfaces enable and how this digital connectivity at Amazon scale has impacted is a good example. So these platforms became a network of business units that were integrated through the flow of data and information from a software architecture standpoint. Loosely coupled systems, data and software became reusable across apps and departments. So there wasn't single application, there wasn't single organization, there was a combination of making each of these departments to be connected and their applications to be connected through digital means, and basically forbidden that in their case that no key business information flows only through people to people. So of course it doesn't mean that people wouldn't have a conversation, they're just having a different conversation, but the factual information is not opinionated. It's not the information, and the message is not changing through who is passing that information. And that's key information. It's there, basically everyone is working with the same information. So what does this Amazon effect then look like in practice in the economy perspective? So if we talk about what is the technical strategy applied, specific technologies didn't matter, and then what is the effect? So here's an example of Amazon effect when they bought Whole Foods. So they bought this national health food grocery chain in the US market, and this is what happened to all of the other grocery companies. There's Costco Wholesale, there's Walmart, there's Kroger, Target Corporation. So basically, depending on the company, up 5 to 10 or 15% of their stock value evaporated immediately after Amazon bought Whole Foods. So this is a market response. What happens when an Amazon comes into the new industry? And basically, here's some numbers from that transaction. So after Amazon announced that it was buying Whole Foods for 13.7 cash, that was I think billion all cash deal shares, as how much the shares dropped. And basically what happened, this is what was part of the research I was involved when we did about platform economy for Finnish government. This was one of the case examples that we used, was that basically the price that Amazon paid to buy the Whole Foods, Amazon's own stock price rise more than what they paid for the Whole Foods. So basically it means that the price that they paid, they got it for free. So it just shows like how a company, for where does their competitive advantage come from? It doesn't come from them knowing how to build digital products for markets. It comes from them knowing how to digitally operate their organization at scale, and then becoming really good at it. And then how does that apply to the markets when they enter a market that is basically working with those analog companies trying to go through their own digital transformations still 17 years later. So just from the terminology perspective, this digital platform economy is a key term. It's something that maybe you want to put into a Google alert and have this platform economy or digital transformation, put those to Google alert and have that alert feed your email with knowledge about some of these key terminology. But this platform economy is the combination of having both the consumers and users on the other side and supply and producers on the other side. And of course, we can think of Amazon store like that. We can think of Uber like that. We can think of Apple App Store like that. We can look at Facebook like that. So those are the platform business models. And again, it's a business model. It's not about the digital first. It's about having a business model combined and accelerated with digital and removing all the noise, basically the unclarity from the model to operate and making it data driven. But behind these digital platforms are also the digital ecosystems. And the difference between the ecosystems at digital side and these platforms are that platforms are they are more understandable. They are easier to understand. Facebook as a platform, or Amazon as a platform, or App Store as a platform, and then even an operating system as a platform, and then an ecosystem. But when we think of digital ecosystems also without the platforms, we just think of them as digital ecosystems, then that's where we get closer to what innovation ecosystems are, what entrepreneurship ecosystems are, what startup ecosystems are, is that there isn't just platform or one system and then connections to that, but there is this whole set of different assets and applications and actors and services and functions that form that ecosystem. And the key is how to build the digital connectivity within that ecosystem in the right way. So it cannot be a platform approach alone. That's not extensive enough, but it needs to be able to function between multiple platforms and also digital applications that are not platforms. So I'll stop here just to check if there is any questions at this point before continuing.
Yes, we got 2 questions. So the first one from Tyler. He wanted to ask, what recommendations do you have for contributing to the data set?
Okay, thanks Tyler for the question. So the key part is really to look at it not from the digital first, but the business or the benefit side first. So a simple thing to start is really to think of what data do I have that would be valuable to others. So is there like others, like if it's valuable to me, why is it valuable to me or our organization or manager? And if so, how could we make that data available? Like what data do we have that we could share? And if we have that, then let's share it. Then that's a starting point. And then asking that question the other way around, what data I'm not having that I know another organization would most likely have, and could they make it available. And the question also relates to that how to make that available, whether it's you sharing data to others or whether it's you asking data from others, is that how is the technical question, and also ownership question, and also a question in regards of, for example, showing only limited data, for example, not sharing names of individuals and things like that, but more statistical data and so forth. So really looking at it from the practical part. What data do I have that would be interesting for others? What data could I inform others that I would be interested in using if you have it? And this is a type of information that we are happy to collect from you, so that you can say that to us, and we can ask that from you, and we can make those perspectives communicated back to everyone, again, saying that these are the types of data that others are asking if you have it, and these are the type of data that others would be willing to share if you're interested in having. So that's the starting point. And then beyond that is then the innovators. So one key aspect is also that is happening, for example, a lot in the public services, specifically in Europe, is called open data. And that basically means that when public organizations basically work with tax money, so all of their services and solutions that accumulate that data is already paid for by the citizens, so that then they have there are organizations that have a notion that we share all the data that we can share, even if we don't know what it could be used for. And then innovators take on that data and they come up with great solutions, and they create new applications on top of that. For example, a good example here in Finland was that the city of Helsinki made the public transportation data available, and then basically some individual app developer created this road guide that basically you just said, I want to go from here to here, and it automatically created you the road and the bus lines and the metros to take, and told you where to switch, and showing on the map if you needed to walk somewhere, and so forth.
Yes, and we have another question. Winnie would like to know, how do you see the ecosystems manage competitions?
So it's a good question, and it's a similar development, I would say, that you can see happening also between the big corporation and organization. There is a term called what is it? It's a combination of competitive, competing, and collaborating, and it's like a merged word. I think it's operating or something like that. I need to Google that, but there's a word for that. So there's a term also to look into. It's basically we're knowing that those types of things, that there is no competitiveness benefit by limiting access to resources. An analogy and an example could be an e-commerce store. So I would say that if you are not Amazon, if you are any other e-commerce store than Amazon or Alibaba or any of these big actors, you can do very little competitiveness in your e-commerce store by developing your own software versus focusing on what products do you actually offer in that e-commerce store, how do you handle the customer feedback, how do you handle the deliveries, how do you handle the customer experience overall, versus developing the software and trying to be competitive in that. So those who develop software for e-commerce stores can develop that software collectively to everyone, and everyone can just automatically get new features and benefits and so forth. But that's one example. But really it is to more look at this shared asset development. All the ecosystems from our perspective are struggling with limited resources. And with those limited resources, it's impossible to do everything. So it's much faster to create collective assets, and it's more the competitiveness is how do you use them, where do you apply them, and then that depends on the strategies at place, how open or non-open you would like to be. But our recommendation is to make everything so that you can share, so that when you can want to change your strategy to I want to share or I don't want to share. It's more of a switch of a button instead of when you decide, oh, I would want to share, but you have no infrastructure to do so. So basically that is not a decision you can actually make. So these are some considerations for that topic. But also I would say that more and more this sharing, like if you look at Tesla opening all of their patents for electric car related things to let competitors catch up, is a great example of where the world is heading. Even Microsoft opening and open sourcing a lot of their patents and applications these days. So the world is moving so fast forward that typically those that hold back, nobody wants to work with them, and as such they are basically outside of the game, and they can only compete with their own resources, which they have less and less resources available because they try to limit the access to their resources from others. One of the key aspects, as mentioned, was really to try to help bridge the difference between like not doing technical deep dive. We'll do that a little bit, and we can go even further as much as needed, and also on the business side that not focusing only on that level thing. So we hear these terms a lot when we talk on either side, that there is this technical stuff that yeah, we understand we're developing the ecosystem, but there's the technical stuff is that's something that it's our supplier or it's our, you know, some of the developer guys, and they'll figure it out, and we trust them, they do everything right. And at the same time, we know that there's a very limited access to knowledge, and we know that the technical side and people minds also develop relatively slow. There's an enormous pace on the technology development. It's exhausting to also keep learning new things all over and over time. So the more they can utilize what they have already learned, the more they have existing softwares that they can apply, then that's usually what they like to do. As specifically if they're doing that as their business, then they have to, of course, get benefits out of their investments. So, but that's one part. And on the business side is then focusing on the things, but not properly documenting, for example, what would be needed from the technical solution, or not giving enough rationale, or communicating in a way that doesn't resonate with the developer for structurally how to do it, or other parts. So we really try to help also work on this wall that exists between these two worlds. So if we look at from the normal users, kind of the business side of this is how applications look to us. It's basically the user interface and what we can do with that. That's how the software has pretty much been all the time, regardless if it was installed locally to our computers or whether we use it online. It's pretty much the same. What is different is what happens behind that, and that's the key thing that we want to open up also now a bit more. So this is the kind of the box of software approach, the mindset of how the business side, regular users think about software. It's pretty much been the same for decades and decades, and it still is, even if it's into internet. We go somewhere to consume an application, we use it from the interface, and that's our experience from it. And of course, when we look at these side by side, then depending on whether they are front-end developers or back-end developers, for them, user interface is not really an efficient way to even communicate with the software. They have always started by just commanding the software to do, the operating system to do whatever it needs to do, and user interface is like, it's like, why do you need to do such a simplified, complex thing when you can just ask things from computer? So this is the kind of the two different worlds that we want to try to help bridge. So what's in the box? So if we look from the user interface perspective, we have, of course, the interface there. We have the users that are using the interface. Already from business side, we need someone to provide user support for these users that are using the interface. So customers or suppliers, whoever they are, but they're the users using the interface, and we need people to support that use at some level, whether it's only like having a call center or whether that's just writing documentation, giving them access to send emails, responding to those emails, and so forth. Then we have the actual software there that makes things happen. That's the code, the magic there. And then we have the data. And this is basically the what's in the box in the very high level. So to the next level, we already need then application developers. We need a user interface designer who makes those features available for the users. And we also need a server where all of this software is run, whether that's a local computer, whether that's a server in our company, or whether that's a server in Amazon Cloud or Google Cloud or somewhere. We need to run this package of software. But not only that, then we also need server software that runs, makes that virtual server run to operate that software. And for that, we need a server administrator who looks so that the server software is up to date and that server capacity is enough and so forth. So there's a lot of these different things. So next thing, if we now would like to open our application to others, whether that's sharing our data or we want to share the features of our software to others, so that we would let other applications, for example, do a query of data from our system directly without going to user interface. We need someone to develop the API interface so that there's application users. Now there could be other applications, but there are of course developer users, other developers who will need to create that connection. The first place, the applications can't connect automatically. And for developers, they also need a user interface, even if they don't like them, but they have a different user interface. So for developers, the user interface is the documentation about the application programming interface. And usually that requires a separate website for presenting that documentation and explaining the API for the developers, because the application cannot connect without some developer making it happen first. So to make that happen in the organization now, there needs to be someone who creates documentation for the developers, someone who develops the actual application interface, and there needs to be a support person for the developers as well. So this is kind of the full setup if you would run your own software, to develop it, to improve it, to run it on the server, and so forth. So when we look at the innovation ecosystem, including the startup ecosystem and also the entrepreneurship ecosystem in context, it has a lot of data and information. So there's millions of ideas, entrepreneurs, startups, investors, mentors, talent, IPs, event, pitching sessions, pitching evaluations, funding applications, and funding evaluations, and so forth. And the digital ecosystem connectivity is the key factor here. So that's how to start building this connectivity. And basically it means that we already have multiple of these platforms that, going back to that platform economy image, we have a lot of these platforms. We have Salesforce, other CRMs, we have Excels, we have Google Drives, we have spreadsheets online, we have AngelList, LinkedIn, MailChimp, F6S, Eventbrite, Weebly, Meetup. There's just a lot of platforms, and this is just a small snapshot. But just to adding another platform or a portal for the ecosystem, it doesn't fix the problem, it just adds to it. Now the information is even more distributed, scattered in that sense that it's harder to find and it's harder to know what data to trust and so forth. So also trying to force everyone to use any single application simply does not work. And why so? Because nobody has ability to dictate to all the free individuals and free companies in a free market to say what applications they should use. They can even bribe it because it goes to show multiple things that there can't be all the features available. There is a learning curve and so forth and so forth. So what we have gone through is to make sure that that learning is validated. So we have spent with an application like a monolithic single application approach several years and a lot of money in real markets to try to see whether that could be made to work before we can say that for sure that's not the approach. It should be obvious, but that's how you learn things that also from technical perspective, a lot of these things would have not been cost effective enough in the past to be able to be done in any other way. But the technology has changed significantly. So I'll get back to that a little bit. But to share a little bit of that architecture that we have already had like since 2010 that we have worked in different aspects, getting it to certain level, but not for ecosystem level, has been basically the kind of model that in a high level there's a person profile in the system, and then there's a startup profile in the system that includes the people profiles who are part of the team, just kind of having the basic information available. And then having these communities this can be an event or accelerator or incubator, that then this community profile includes the basic information of any community and has the community team members, community team profiles there, has people member profiles and startup member profiles. So this is kind of the basic architecture that we have worked for several years and what information and data should flow here. And then in the community, there's features like events, news, jobs, discussion boards, and so forth. And then having this one application to connect these communities, anyone to open their own communities and share information and share profiles between the communities. And then the ecosystem would be the combination of these communities and having this architecture basically to grow, to be able to include the key elements and assets of any ecosystem. And then there could be city ecosystem as one group, another city as one group that could have these shareable assets. But the key point here is that on the architecture point of view, this very much is as true today as it was years ago, and it will be as true 10 years from now as it is today. So the architectural consideration is solid, but then it is how to design this as a digital ecosystem level solution and not as a platform. So you have some snapshot of how the application was looking like. We have community dashboard, we have community menu of elements there, and then there's the individual user's profile and access to that, coordinating workspaces, managing your own profile, managing your startup team communication, and also various different functions for that, managing the community members through a more CRM perspective, but where it's behind this information is an actual profile and an owner of a profile on the other side, to have more two-sided communication instead of one-sided CRM communication of customer records versus actual profiles of customers with their own communication on the other side. Same with the startup profiles, having the company's basic details of those, the team members, their profiles, activity list, for mentor, for example, how to interact with the customers and so forth. So one more here to show a pitch training scorecard application to have this model how to do systematic scoring of startup pitch events and collect that data from the jury in the application and in the system, also to get directly to the startups that were evaluated and to collect information that can be then decided separately how to share that with other communities and so forth. So that's what we have already gone through. So there is no point of building that type of approach on a platform approach because it does not work. So the challenge with that is that none of the ecosystems start with no applications in place. So it would start from replacing these applications. At the same time, all of the existing applications also already include extremely valuable data. So the challenge is more of how to apply that architectural thinking of the type of information from that architecture to the existing ecosystem so that you don't have to start replacing things, but you can actually start making that information flow. And then also, going forward, you can develop new applications on top of that without needing to kill the other models and train all the different users of those existing applications. So this is the key challenge. And when we multiply those connections, we start to see the scalability problem of doing this at scale for local ecosystem, between local ecosystems, to national ecosystems, to state level ecosystems, to connecting between local ecosystems in different countries and so forth. For any individual application, in the beginning you can have 3 applications and 3 connections, so shouldn't be too hard to create those connections. But at the end of it, if you have like 14 applications, and that's not even a lot if you think an ecosystem, you already have 91 connections. And each of these would require the ones who create the APIs, provide the documentation, the website to support the APIs for the connectivity, and then those who would actually proactively build the connections to other applications and do it multiple times over and find a consensus between how to do that. So clearly there needs to be a different approach and a strategy applied. Another challenge that came about in those past 5 years, and that was a challenge on one hand, but a significant opportunity on the other hand, was the data protection and how individuals' data should be considered when the technology is developed forward and how in the future they should act. And mainly these are in the Europe, it's the GDPR, it's the most globally known regulation, but it's not the only regulation. There are a couple that I highlight here. CCPA, which is the California Consumer Privacy Act, that is coming into effect next year, 2020. GDPR regulation is already in effect today. And then there's also LGPD regulation coming into effect next year in Brazil, and that's a similar data protection law. And there's similar regulatory developments following this regulatory development in many different countries. And what that basically does is that it forces all the companies, all the organizations to give more control for their customers, for the individuals, to give them the data that you have in your system, and also data about transactions and activities related to that customer or individual. So this goes into individual protection. So individuals have right to ask data removed from any system, and they have right to ask to have their data in technically readable format in their own possession. And in Europe, this is already in force for more than 500 million people, and there's high penalties if not complying with this regulation. So this applies equally to Facebook and Google as it applies to public organizations, as it applies to small coffee shop. So it's a blanket regulation. But the upside of this is that it actually makes that data portable. So the key aspect is that now it's not no longer in control of any company, including Facebook or Google, to limit individuals' right to take their data about them and give it to any other application they want. The problem is that there is very little technical solutions how they could actually do that. So while they can get their data set out of any application, and the organization have to comply with that within 1 month time, there isn't really how they can do it and where they can put it. But this is something that this regulation is only accelerating forward and spreading globally. So it is a new paradigm for how to consider the consumers or customers' data. At this point, it applies to individuals, but when starting to build these technical solutions for making it happen, the next logical step is apply that to freelancers, to SMEs, to companies also to be able to take company customer information from one system to another, even though regulation doesn't dictate that yet, at least. But that's a logical competitive advantage that organizations can start to build, making that happen. To understand more about this concept and so forth, there's a great white paper done and a separate whole movement behind this by my data, a lot of well-documented information available. So I recommend to look into that. And if you want to do even deeper dive, they have also an event happening later this year, a global event to go learn about various different aspects of this development. But the key here is that this brings another type of consideration for the overall infrastructure, both from the problem that needs to be solved, but at the same time, an opportunity to utilize that for more effective information flow within the ecosystem. Getting back to that very beginning part of how does a global revolution start? So how do we now, what are we now launching? What are we now about to do? And it's really, from our perspective, we've been doing and kind of looking at the market timing also from the perspective of where the collective mindsets are in regards of this ecosystem development and openness and competitiveness and collaboration and so forth. And now we start to feel comfortable that there is enough understanding for us to also initiate this type of approach where there's enough audience, there's enough of that momentum more from the bottom up that wants to also start to look things from this perspective instead of kind of this top-down national level bigger projects that we have been doing, that where also those top-down actors are very much supportive to this type of development. Of course, it requires a lot of detailed consideration on multiple levels, but the top level mindset is aligned. And as a company closely associated with innovation and building new, creating new things, and helping others to do that, the only logical step for us is to start this bottom-up approach. So basically, it means that we'll need to find and identify these different actors, those who want to start driving this from bottom up, from within their ecosystem, from simple step-by-step approach, and identifying more and more of those, spreading the information, bringing those people together in the forum like what we are doing here, and then going from there. So at this point, we feel that there is a right combination of real demand coming from ecosystems around the world to this type of level, data as a key resource of this digital revolution. Technology as an enabler exists there. We've spent in the past 2 years significant time on these technology developments and re-evaluating and building prototypes and building smaller projects to put these things into place, to see them in function in practice, that we feel that we can start to put out that more self-driven, iterative, documented approach. So there's adoptions coming from different ecosystems, needs and maturity levels. So the timing factor starts to be really good for us now. So to make that visible, not only by what we can say and what we can talk, a key aspect is that we seek for those who commit and basically raise their hand and say, we agree on this approach. We want to drive this type of thinking. We understand enough. We want to do something, and then sharing what they want to do and what they are starting to do and what they are doing. And here's these people we want to support, these organizations we want to support, and for them we are starting to provide this knowledge and information and putting that openly available resources, assets, tools, code, software. But we need also to align our thoughts so that we are collectively in the understanding of which direction we are going and why. So it comes down to setting this global joint movement and starting to work on practical things, open standards framework, and the declaration for that. So moving from isolation to openness, from silos to interoperability, from do-it-your-own to collaborative development, from product to ecosystem users and output-focused approaches, and really thinking it all the time at fully scalable, regardless of geographics and business verticals. So really the key here is to look at this as a collaborative effort and then basically asking who's going to join us. And to make that really practical, we are launching a website where you can go and basically read the declaration, kind of the basic principles of this movement, and basically sign up for that. And then we'll start list the organizations that are taking part into this and hopefully grow that list for the benefit of everyone, to seeing who's on board, who's joining, and to also be able to start collaborating. What data do you have? What data I have that I could share? And based on this, we facilitate the development of this open standard data model and basically start developing the tools, the self-use tools to start building those connectivities from your side without needing direct permission or resources or anything that you couldn't access directly from us, so that you can start doing that. But it starts from this: I'm on board, so I commit, I'm on board, let's do it, I want to start doing this, and then we'll start to work on that, and we'll help coordinate this. So the key part is really that we want to build this frictionless ecosystem globally over time, and we want to set it in such motion where hopefully, like the similar as open source software developments, that we want to keep it as open so that it's beyond our control in a positive sense, that we can only control iterative development of this open standard, but we cannot control like the usage or access of that, because that needs to exist in local levels, and the responsibilities and regulations and how they apply in different countries. So we'll support, provide the tools, we'll provide guidance, but we don't build vendor locks. So FreeClinex ecosystem, fully open, connected, scalable to serve all ecosystem players and stakeholders. So this is what we want to enable. So I already discussed about these two different tracks. So far we have been working on this bigger one-way approach, that we do these bigger project-based approaches, so that we work through an ecosystem key actors who invite us to join, to help develop, to bring them knowledge, information, expertise, and then we start to develop step by step with them with the project-based approach. And this is specifically for ecosystems, in that if we think of the global ranking list, those who have resources, they want to lead, show the way to others. They have no problem of doing like test and learn and failure sites along the way. Anyone who wants to really push the envelope and drive their ecosystem, or those who are very much behind and they really need to catch up to try to get more in the peer level with others. So we typically are working with both sides, and of course everything in between through these project approaches, because it's been the only way that we have basically made these tools and assets available. But now we are launching this independently initiating iterative approach, so that where there is no need to wait for others, ask for permissions, or try to get budgets for like collaborative, so that individual developer can start, the developer of an application or one who is supporting their ecosystem application, or someone, even a startup who is creating a software for ecosystem purposes, for any of those to start benefiting from this collaborative resources. And then we develop this site over time. So we are now just launching. It will take its own time. We will also start simple, so that it's easy way for everyone also to catch up, to align with those who want to start with something simple. We want to support that, and then we, at global level, we aggregate and collaborate more and provide more and more to support that initiative. So we both create ourselves and we take contributions from others and make those available to others, and really do that as a collaborative effort. And of course, there is no, like, these are not separate tracks. There can be switch track to either direction, whether it's starting from track 2 to move to track 1, or whether there's already track 1 going and then moving the project to a certain point and then making it more and more rely on the track 2 type of strategies and approaches. So we just want to make sure that there is enough functionalities available, enough infrastructure becomes available for that independently initiated connectivity building, and then we, at the same time, we are not restricting to move out of utilizing our support or infrastructure and so forth. So that handoff can happen also when there's enough ability to take on the ecosystem operator type of roles to organize multiple different things at local ecosystem level. So key building blocks for this is the data infrastructure for interoperability, aggregation, comparability, and so forth. So it really comes down to, when we look at that big picture about the software application, it's very little about user interface level. It's very little about software functions and features level in the beginning. In the beginning, we will start from directly going into the data and focusing on how to help that data to be shared. And there, the key part is the open standard for data model. Basically connecting to that conversation of what data do you have that you would like to share, what data would you be interested in having, and that's very much a conversation that can happen both at developer level and also at business user level, even with at any level. It's something that we can all collectively understand, and then the technology around is then to help make that happen. How do we do it? But we'll start with the data approach, and over time we will make more software available, hopefully software that is compliant with that data model, software developed by others. We are happy to support the marketplace approach for that, and also eventually bring more of reusable components also for the user interface level. So the key building blocks are data assets, such as datasets, identifiers, registers, standards, technologies, APIs, guidance, policies, helping to set up organizations or teams to govern the data sharing infrastructures, and so forth. So on one hand, it's knowledge related to these things, documented knowledge, and on the other hand, it's actual tools to build with. So to really adopt these open standards, they are basically the starting point is the declaration, and that leads into coming to use with the terminology and applying the terminology. So those that are not yet technical, it's like not digital constraints, it's more of the soft part of leading towards the right common direction, and then looking at the ecosystem operator level. Is there a local ecosystem operator who starts to look at the connectivity and enabling the connectivity and supporting the infrastructure locally? So that's specifically for the project-based approach that we are already doing. But even so, we can act as an ecosystem operator that some of these key functions can already be run through us. At any point, they can be handed off to a local ecosystem operator. But for the sake of being able to start from a bottom up, we enable that. And then there is the data sharing that is actually already happening. And then there's the intelligence. So then there is more advanced services, whether that's AI services or whether that's just more data-driven policy making or so forth. But it can only happen when there's like primary data, real, factual, truth data, not surveys, not feedback, not opinion, but actual factual transactional data and statistical data collected and flowing. These are like the different ways how to adopt the open standards in practice. So there's compliance levels with in context of like how much of applications are utilizing these data models, the processes and standard procedures that are like the common best practices that are also put out there for improvement and iterations with others, having services, policies, systems, and a lot of this compliance is more that when we know there's an application by a developer saying that, okay, we are utilizing this data model for sharing this type of data, we have implemented it, it's available, then we can inform others that, hey, now there's an application that is utilizing this concept, so therefore you understand what they're doing, it's easier to connect with them, it's an open standard, and same apply that when there's processes and procedures, services, policies that are based on these common open standards, then the more compliance and the more connectivity can be built much faster. And this can be within the context of single ecosystem or specifically between ecosystems, between different cities or between different countries. But the key part is that these are open standards. It's the only way how we can collectively make this happen, because if we all build our own models, we can forget the connectivity, we can forget the benefits of what private companies can do on their own for their own business, but they can never do that at the national or full sector level, because that's not healthy to any city or any country. So as a global joint movement, open standard framework principles and declaration is really from isolation to openness, from silo to interoperability, from do-it-yourself to including third parties, from product to ecosystem, user-focused, and so forth. The open standard data model is the core key piece where we are doing the work, the heavy lifting of documenting, hosting, and iterating, the same way as you have probably come across with our startup development phases, or if not from us, then you can think of similarly as like business model canvas. That there's the business model canvas, it's under Creative Commons, it's openly used. The same applies for data model, which basically helps to communicate what data are we sharing, in what format, and how to access that. So these data models are collaboratively built and combined expertise with startup ecosystem development, innovation, entrepreneurship, and digital economy technologies. So really bringing these worlds together to make sense out of that data model. And here I want to reflect back to that architecture that we already started with the single application approach already 5 years ago. So very much the data model is very much the same as it has been for several years. But instead of using with our proprietary approach, we'll just apply that knowledge into this open standard and involve the contributions of others and have a governance structure that we will build around that, including the more we have others taking responsibility of that, the better. We're here just to make sure that someone takes initially some responsibility of moving that forward. So the ongoing development, of course, on the basis of open decision-making processes and so forth, and then permissible for anyone to copy, distribute, and use freely. And here's just a kind of a top view, also looking back at that earlier architecture model of the type of model, data model categories that includes like people and entities, being that startups and other types of companies like SMEs, a little bit of different data, but it's the similar logic. Support services and activities, then ecosystem development initiatives and projects, and then more of the statistical data, reporting, key performance indicators. And then really function-focused segments like how to build companies. So these are more like process-based perspective, building companies or providing support functions or operating at ecosystem operator for managing and development, or working on the digital side to provide tools and solutions. And then content model groups are like listed data or owned data. So more of the public facing open data, or then something that specifically there's a consent given for access some of the data when needed. So two kind of key groups in that sense. And here's just a kind of visual representation. This is something that as a developer, it is similar to looking at database model, but it's not a database model because it's not looking at whether it's database, MySQL, NoSQL, data lake, or whatever way of structuring that data. It's just that the data structure, a data model, and for business user, you can easily identify that what type of data is in each of these data elements and how do they connect to each other. So it's very much readable on both sides, and this is why we want to bring the data model into center of everything from the very beginning, because ultimately it comes down to the data. So we want to start with that, and then all the other things that make that data flow, and how it can be utilized, those technologies will evolve, but the why we are doing that, they very much is the data itself. So it's a common denominator for all types of ways of handling and sharing data. So whether it's to design a new application, whether that's a design of database, whether that's for collecting and storing research data, whether that's designing an API, developing or documenting it, using it, or whether that's for sharing data manually in spreadsheets, in any technical format, through any technical solution. It doesn't matter, this type of data model is the centerpiece for this development. The other part related to the business side, so the non-technical side, and how to bridge the non-technical side ecosystem activities with those who work on the invisible infrastructure to make it more tangible through digital tools, is to how to or set up these kind of activities in the ecosystem level. So we have a lot of information available on our site about ecosystem operator role and its purpose and function to really become the one that looks from a neutral perspective locally, this ecosystem, digital ecosystem infrastructure development, but then how to combine the activities from the bottom up, the non-technical side with this, is to how to organize an ecosystem forum function, and through that function to work with different bottom-up task forces on specific items. And then the operator's role is to really help aggregate this information, use the ecosystem forum to help prioritize the information, and then also raise conclusions and outcomes out of the data that is already flowing, and help keep focus on the development objectives that are active in the ecosystem and so forth. So really combining the long-term sustainability, ongoing infrastructure type of development with the non-technical business side and business activities development, and more iterative, faster tests and so forth, but without making the infrastructure to be something that never gets longer term perspective. And then having a governance represented by the ecosystem forum actors on this ecosystem advisory board. So here's a snapshot of how to organize these activities at the local level. And this is the model that we have applied in the project approaches for, but we will start sharing more and more of this information to help bring these technical and non-technical worlds together, and also how to organize these activities. And the more they are open standards and shared best practices, the more they can develop, and more different ecosystems can better understand and share and collaboratively develop with the limited resources. A bit more from the data infrastructure. So if we're bringing back more of the analogy from this setup and going back to that, how is a typical application? There's the user interface, and that is how users see it. Then there's the business logic and the data access layer, and then there's the database. So there's the code includes this. And this is pretty much for any type of application, with the CRM, event system, platforms, and so forth. And the reality is that these applications are really, with closed databases, they are like these wells. They are like these silos that have limited use. Only those who have the application, who have the access, they basically put data in, or the data gets from put by others, and then you pull it out. And that's as efficient as that application is. And then this information is shared manually between people. So people pull that information out, send it as a report or PDF or conversation to tell what's happening on the other side, and there is no access for the other system's data. So data sharing is very, very manual. It's random. It's per request, and the accuracy of the data is often unknown. Whether it's outdated, what does it include, what doesn't include, and so forth. And then this application-to-application sharing is through the API application programming interface. So now the information can flow from the application to another. So now this is already more automating data sharing, but to really get into the level of being able to share at ecosystem level, not just between a couple of applications, it requires something else, and that's where the ecosystem OS as the open standard-based approach comes to picture. So now we are building data flows, so we are building those flows behind these applications for maximum use, flow, and distribution. So really going from these data silos to data pipes. And building and operating the pipes, like any other infrastructure, it requires, like buildings, cities, roads, water systems, it really requires proper resourcing for development, operating, and maintenance. And this is where it connects between making that type of infrastructure available for the bottom-up approach. So that's what we are starting to put in place step by step, or then it is to setting up that operator to the project approach and starting from more of a bigger resources and making that available for the ecosystem at national or local level. So custom built for local needs, but built with global knowledge and expertise, best practices, and common standards. So just like you build bridges or roads or other systems, you rely on these standards so that you know what are the road signs, so that they are logical for people from another country, instead of having totally own set of road signs or the length of the road or the width of the road or road markings and so forth. So these shared things, the commons, is a key part. There's many things to work on. And the point again is that this is when it goes to ecosystem level, there's a lot of different items to work on, but when doing step by step, there's only limited things that come to across, but it's important to have these different considerations when doing those activities. And on the policy solution level, becomes what tools and terms are used in own service, what tools and terms are recommended to others, and so forth and so forth. And knowledge building solution level, it's to educate and train about the resources, manage, support, and further develop, and so forth. All of these are more of the collective effort, making it easier for others to access and start using more of the bottom-up approach. And technical solution level, ecosystem level database and infrastructure to connect support services, functionalities and features to support service processes, flexibility to make changes and develop central infrastructure, and so forth. So these are all different considerations for along the way. And it really comes down to looking at the ecosystem, that it serves the whole city or region or country in a way that the information actually flows between the applications and not only between people. So when we apply all of these learnings and the technology developments from over the years with the monolithic applications, the technical development has really significantly taken a fast forward around 2014, and it really has driven the microservices API gateway development at significant level, and it just shows some of the terminology on the application side development. And here's also a snapshot of some of the more technical terminology of how to do things, what are being done, and where is that happening on the solution level, and how the traditional models have been, what are becoming outdated models, what are the current models, and what are the emerging models. And these are more of the terminology to help connect and get an idea of what's happening. And each of these terms, for anyone who's interested to learn more about these core elements and principles, is a good simple way that I use for myself is put a Google alert for those terms and let Google feed you findings like per day or per week, and periodically read those articles that come, and you pretty quickly get a sense of what are those topics about. And this is equally for technical people and for business people, because for everyone, the newer the technologies are, everyone has to learn them. It's not like technology people automatically know new technologies without learning, so it's equally same. So what we have done in the past couple of years is really breaking things into pieces to be able to utilize and take benefit of all of those learnings. So it's really to start building and breaking the user interface side into individual components, and this is more where we will get, once we get further along, we'll start to share also more assets on this side, but really we focus on this data infrastructure level of how do we connect information from those who have it, from those who would benefit from this information, and really looking at it from that perspective. So this is the beginning part of our focus, but it's all about breaking things down into individual streams and individual components, individual functions, and doing those one by one, and then accumulating that inventory over time in collaboration with those who have information to share, and with those who want to get access to information that others have to share. So it's all about transitioning to this serverless architecture more or less. So this is for technical team side, but also giving an idea for business side of what's happening there behind the application. So in addition to looking at that infrastructure, it's about building this connectivity from individual applications through this shared infrastructure to make the data flow through single connections without needing to create multiple connections between each of the applications. So having this shared data infrastructure to make that flow. And then on the other hand, this goes back to that individual user privacy. So my data models, and also towards the GDPR regulation, CCPA regulation in California coming into effect next year. And of course, that is a very big thing for how many things coming from Silicon Valley will start to shape up when the new type of regulation also comes into effect there, to start to take into account this information flow from application to another through an individual user. So here we have the concept for ecosystem user account, that we will start operating one, but that where it is also that it can be transferred into any other operator who is operating similar infrastructure. So that is the approach. We don't want to be the global user account operator for all of the ecosystems and all the users in all the ecosystems. That would be not our focus. our focus is to provide the technologies and solutions, show them, bring them enough available so that others can start to use them, and then apply them, the model, or move that model or move that use into their own, under their own ecosystem operator. And again, that applies between these two tracks, that it can start from project-based approach and move to more iterative, or it can start iteratively utilizing our infrastructures and us as a limited operator with limited capacity, but then moving on to taking that into own control by establishing the ecosystem operator. And how these come together is now a certain type of data, like the service data, statistical data, specific organization or function specific data can be made to flow through the infrastructure. And whenever it is information that is attached to a customer or user, so that can be the mentor, the individual talent, or the startup that they have put together, the information can flow under their consent through their account to another application. And it can be made flow as real time as possible, or it can be per request, per use, and then not having that data anymore available based, because this is the rights that are dictated by the regulation as the way of how this type of data should flow. So if we look at the evolution of the software architecture, it comes down to this unbundling of different applications. So it really is about mobile. Basically, if you look at some of the pictures here, it's moving from this monolithic application where basically the APIs were initially created to support mobile apps, and then the business logic and all software features were packaged into there, and the data model was basically only on the database level. To then these more open application architectures, where the data model and business logic started to live outside of this one application, and then into this serverless architecture that then starts to have more and more of this overall structure, shareable, modular, and individually documented, and at the same time separating the business logic, documentations, and so forth for the further outside of the application. And that is the key thing for equally for Amazon's success as it is for the success of the digital ecosystems, is that more and more of these are individual pieces that can be restructured while they can be at the same time shared and used. So data is one, and then the other assets like these software features is another one, and entire applications that are compliant with these data models are then the third key piece. So the business and data logic design at front-end level really no longer is in deep in the system, somewhere there behind the technical stuff with complex dependencies. The cost factors, the cost has significantly gone down all the time, and that cost factor is similar as it has been for the past 10-15 years. How the technology cost is going down, it continues on the same curve. What it basically means that more capabilities become available to anyone, cheaper and faster, and the big guys competing with themselves, Google's, IBM's, Oracle's, Amazon's, so forth, make sure that that competition continues. So really it comes from this monolithic application, maintaining own servers, operating systems, to mobile apps. And the common things that are really the key things to follow here is that first, the common thing is the data model. That's the beginning part. And when there's other applications using that, that's the data model is the key piece. Regardless of how that connection is built, the key question is, what are we connecting with? And ecosystem data is then taking it to that level, makes it more shareable between the all applications. And then when we look at the software side, basically that is to breaking down these monolithic applications into these microservices. And even though they have more software, to breaking it down even more to individual functions. And now you can see how the common parts are growing from data model to business logic to API documentations to individual features and ultimately also to shareable users through this application, the user account at ecosystem level. So also sharing users and users' data. So really it's bringing more order from this monolithic spaghetti into breaking it down and making these assets more available, and then building with these assets more connectivity and having more common things to share. And then finally, enabling totally new ecosystem applications to be built on top of this that are no longer need to be monolithic applications at all. So this is really the key on the infrastructure side, also to break it down into pieces, document them properly, making those pieces reusable between multiple different users. So one of the key parts that we will make available is going to be to share your data easily with others, and initially starting with so that you don't have to start creating your own APIs for your own application that requires the documentation, developer website, and so forth, but to be able to share that data in more multiple different formats, from automated spreadsheets or so forth, and we'll make that data available as long as it's compliant with the open standard data model, to be making that data available and start providing APIs for others to consume, including those in your ecosystem, and growing this step by step over time. And at any point, if you want to start operating your own ecosystem OS or any other type of infrastructure solution based on the open standard data models, you can more easily do so because there is no, it's based on the open standards. So I know we are a bit over time, but if you need to skip from the remaining part, we have about maybe 10 minutes left for the material. We will share the recording with all of you. So here's a typically occurring use case to in a simple way what this kind of better data can do. That happens a lot. That is repeating many places. So here's an example. This was just a random. It's actually from June, just very recent. So it was a. It's not something that had to even look for far. It's like, what's wrong with this picture is that there's a lot of events happening on Tuesday at the same time by many different organizations. So for some reason, maybe some statistical perspective says that Tuesday afternoons are the best times to organize a meetup or an event, but these are all by different organizations at different times. At the same time, they probably have same audience, and now the audience they would like to join their event has a problem to choose which one they should pick because they are happening at the same time versus if they would have happened in different days. So that's a good example. So there's plenty of room on the other days, and nothing's happening there during that week. So an example of how this can be organized is to pull the event information from different event systems like Eventbrite, Meetup, Facebook APIs, where these events are published, collecting only the basic information out of those. When are they happening? Where are they happening? Who is organizing, and the description, and then putting the output of that event into publicly available Google spreadsheet is an example of now everyone could have a collective resource where they could, when they are thinking of organizing their event, they could already see like what other events are being organized and choose a different time. So just a simple use case scenario to help taking the information that exists, making that information more common, and doesn't have to be all details, just the key information of those, and making it easily available through another system. So, but this is just one use case that we are looking to also build a demo to help support this type of use case later this year. So, getting back to final points of how to initiate is to really start with something simple, and the use case that we showed is something relatively simple to start, and really starting to build those things that have end-to-end value, and to start removing the inefficiencies, and one end-to-end data pipe at a time, basically looking at it from that perspective, and then building an inventory of those things that you would like to build over time, sharing that inventory, communicating about that with others, like in the Facebook group or Slack channel that we have created, to basically start working together on solving these things one by one. But for your own ecosystem, when you build that inventory, have a long-term vision of what type of use cases and data you would like to solve. And the key part here is really to don't get confused with this picture when you're starting with something simple, but then have an idea and start keeping inventory of those types of things that you would like to enable. And this is an area where we can have a collective conversation, because the more we are solving same use cases for every ecosystem, the cheaper and faster and better they will work, and the more collective benefit we will gain in this aspect. So we really focus on providing the coordination and contributions for open standard ecosystem framework, specifically for data models and sharing APIs in the beginning. And at the same time, we will focus on providing this global community and open ecosystem developers, operators, and compliant applications, and really driving this digital agenda. We'll build on the documentation, we build on the data models, we build on those APIs that can be used, so that you don't have to build them your own. You can, of course, and you can use the same data model and get the benefit on that. But if you don't have the resources, then you can start sharing the data, and we can start putting that through an API, the data available, which is under your control, when and what data you want to share, and with whom. And basically, through this, we focus on providing these elements. So we will continue to move into other useful assets, and we invite the more others will take ownership of any of these aspects, the happier we are, the more we can all benefit from this. But we have identified that over time we will keep adding these elements into this track 2 approach of bottom-up approach for any organization in the ecosystem, in their own ecosystem, to start building with. And we keep adding these assets and make them available more and more over time. So the shared things is first the data model, then the business logic elements like shared best practices, KPIs, benchmarking, APIs, documentation, then software features, these individual server functions as features, then this Circlepass users and user accounts, so people who can and companies that can move data from one application to another, and then to ecosystem applications. And we move all of these forward depending on how the community themselves, how you want to move forward. So for any aspect you have, items that you want to contribute, that's where you can contribute. And just sharing some of these more detailed architectural considerations for more of how all of these different things work. I'm not going to go through starting to go these into details because of the time constraints, but we will get back to these types of views in the future. We wanted to share these so that you can get a sense of the thoughtfulness of these different applications and how they connect, and have conversations with between the business side and developers on your own ecosystem for what those mean and to see what's coming. So these types of things we will start to document and make more available. So really to kind of get a better sense of how those terminologies come together and what's in our considerations. So now how can you contribute to this? Is basically to really start from the declaration. So just review the declaration. If you want to sign up for that, sign with the simple form, and we'll make your commitment known to others in a separate website, and share your data model. So basically, if you're an application developer, you can take a snapshot of the database. Of course, it should be relevant ecosystem application, and share the data model, not the data itself. We're not interested in the data itself. We're interested in the structure of the data. Share that with us, and we can start aggregating these different requests into the open standard data model that we will then publish and document and take contributions to that in that form. Or you can consider the data that you would like to share or the data that you would like to get and inform us of those, and those contributions go into this open standard data model version development. And of course, if you want to join the effort of doing the actual work, then more than happy to have contributions for that. But realistically, we are not expecting to get too much in the beginning until we get a bit further along. But the door is always open. If you want to contribute, we'll find work for you to do for the global community in this space. So those are the beginning steps. So it's really building this connectivity as a service, and the business model side or the pricing model size that we're looking is that there is no fee for connecting to ecosystem OS. Fees are only based on the data traffic use, because that's where the cost for us running that infrastructure comes from. So we can't extend our support, and if we have to pay for it, then we have to make it at least cost neutral for us. But because there is no cost for us to basically to enable that connectivity itself, so that's also not going to cost to get started. So it's really expand your brand's reach to provide greater value for your customers and users, create services that interact with other applications around the world, better return of investment by reusing existing IT assets, specifically data, low entry barriers, free to be connected, only pay-per-use, or then set up your own infrastructure based on the open standard models at any point where you want to take those on to your own ecosystem operator. And no need to worry initially to get started that you would have to develop your own APIs and to provide support documentation for others to connect into your data. So this is really our thought process behind to getting all of this initiated and making it more enabling that bottom-up approach as well. So let's start the path to connected ecosystems also in this way, and this is really what we wanted to launch and tell what we are about to start doing more after the summer, and the path that you can join and help contribute by signing up for the declaration and joining in our community in the Facebook group, or if you're more technical or just like to learn more technical side things, also to our Slack channel, where we will continue these conversations on any of these topics and provide updates in those channels as well. So finally, before closing, just giving kudos and sharing perspective of those different actors that we are already doing project-based work, or where we are having conversations of initiating this collaboration and finding the work together. There's several others as well, just highlighting some of these where either some of the standards are in use, some of the terminology is used, so some of the existing compliance already exist, or where we have active conversations and where the strategy of starting to work with Startup Commons in the first place have been to seek for this global collaboration approach on the digital side, because the ecosystems will not connect automatically and the data doesn't flow within or between ecosystems without finding the collaborative ways and finding the right controls in place of what data to share to whom and when. So we will continue to repeat this, and we will continue to structure the communication. We will continue to build the support sites and making things more accessible and so forth. But we wanted to really give a complete set and get this session also recorded so that we can use for anyone who really wants to understand this, can and then access also this recording at least, and spend a few hours of their time to really get a sense of what's going to start happening now and how they can expect it to develop in the coming years, and also finding a place how to start and where to start, and also have this asset and resourced in a shareable ways. So we will most likely over time cut this into smaller pieces also for easier delivery and so forth. But thank you everyone, and we will close the session here, and let's connect on the Digital Ecosystem Facebook group and on the other channels, and let's start moving this forward collectively. So thank you everyone.